Welcome back to All This Math. This is Professor Parker, and for today's lesson, we're going to talk about a GCF or GCFs. Now, what is a GCF? GCF is a term that's thrown around loosely by math teachers, math professors, math instructors all over the place. And a lot of times, students just don't even know what a GCF really is. So the purpose of this video is to show you what a GCF is once and for all, in case you don't know what a GCF really is, and to show you how you can find the GCF when you're given a couple of numbers. All right. First off, GCF is an acronym, right? An acronym is a series of letters where each letter represents the first letter in a relevant word, right? So GCF is an acronym that stands for, kind of like an abbreviation, right? Greatest common factor. Greatest common factor. So hopefully you're taking notes, right? You got your pen or your pencil, you got a notebook, or you got some paper, right? You're in a quiet place where you can focus, right? Watching this video. Greatest common factor. Greatest common factor. Now, what do those words mean? Greatest means the biggest, the largest value, right? When you're comparing numbers, which numbers have the largest value? All right, that's greatest. Common, a number that is present in multiple lists. So it's common, right? It's not unique, right? It's not only in one area. It's not only in one place. It's not only a factor of only one number. It's common, right? So it's a factor of multiple numbers. All right. What is a factor? Factor is a term that gets thrown around a lot too. A factor is basically a number that can be multiplied to arrive at a product. Example, 3 and 2 are factors of 6. Why? Because 3 times 2 equals 6, right? 1 and 6 are also factors of 6. Why? Because 1 times 6 equals 6. So numbers that can be multiplied to arrive at a product or a multiple is a synonym for product, are factors, right? They're factors, right? Think of them as like ingredients when you're making something, right? You're making some food. Like, what are the ingredients? The ingredients are similar to factors. Ingredients and factors are synonymous. You mix the ingredients to come up with a product or a final meal, right? That's your product. All right. Now, let's look at these examples. We got 3 examples. Let's look at the first example. So if I give you 5 and 9 and I say, okay, what is the GCF of 5 and 9? Now, until you get really comfortable with this, what I suggest you do is for each of those numbers, you just write down all the factors. Now, how would you know the factors of numbers? I'm going to tell you, if you know your multiplication facts, and again, I always preach about knowing multiplication facts and having them memorized. If you know your multiplication facts, then doing this step will be very easy. If you don't know your multiplication facts, then I suggest you go get a multiplication table and be able to look and see what numbers are factors of other numbers. All right. And also, my suggestion is this: memorize all of the factors of each number from 1 to 150. From 1 to 150. So all the factors of the number 1, the number 2, the number 3, the number 4, the number 5, the number 6, the number 7, all the way up to the number 150. Be able to say them off the top of your head. That will make your math career so much more comfortable and flow so much more smoothly. I promise you. I promise you that. All right. So let's get started with 5 and 9. All right. So let's write down the factors of 5. Now let me give you some other information. 5 is what we call a prime number. Prime number. What's the definition of a prime number? A prime number is a number that only has 2 factors. 2 factors. Memorize that. Write it down. Take a picture of it. Whatever you got to do. Know what a prime number is. A number that only has 2 factors, right? The factors are 1 and itself. There are no other whole numbers. And that's another thing. That's another detail. We can multiply millions and millions of decimals to sometimes arrive at certain numbers, right? But when we talk about factors, we're only concerned with whole numbers or integers, right? We're not talking about decimals. We're not talking about fractions. We're not talking about mixed numbers. We're only concerned with whole numbers. There are only 2 whole numbers that can be multiplied together to equal 5. They are 1 and 5. All right, so that's your complete list of factors for 5. Now, let's list the factors of 9. For 9, I got 1 and 9, because 1 times 9 is 9. And I got 3, because 3 times 3 is 9. Now, I don't need to list 3 2 times, because 3 is, if I list it twice, I'm just listing the same number twice, right? I don't want to double count. So now, these are our list of factors. Now, how do you find the GCF? The GCF, we got to find the greatest common factor. So these are the factors, right? 1 and 5 are the factors of 5. 1, 9, and 3 are the factors of 9, right? So check this out. What is common? What is common in both lists? What is common in both lists? Meaning, what number shows up in both lists? What number shows up in both lists? All right? The 1 shows up in this list and 1 also shows up in this list. All right? Now, sometimes you're going to have lists where you got multiple numbers that show up in both lists. That's why the G for greatest comes into play, right? Because even if you got 3 different numbers that show up in both lists, you got to pick the greatest one or the biggest number out of those 3 numbers. But in this case, only 1 number shows up in both lists. So you don't really got to worry about the greatest part, right? So in this case, the greatest common factor is 1. That's how you find the greatest common factor. The greatest common factor between 5 and 9. So what's the biggest number that they have in common in their list of factors? That's what a GCF is. Now, why do you need to know what GCFs are? Because GCFs come into play when you need to reduce fractions. They come into play when you are in algebra and you're trying to factor expressions, right? Quadratic expressions, cubic expressions. They come into play when you're just doing a whole lot of things, right? You need to be able to, simplify expressions. You need a GCF, right? You need to be able to find the greatest common factor in just a lot of different scenarios and a lot of different situations. All right. Now let's go into the second example, 6 and 14. So I'm gonna write 6 down. I'm gonna rewrite 6, and I'm gonna list all the factors of 6. Now 6 is not a prime number, all right? Because 6 is what we call a composite number, just like 9. 9 is a composite number. A composite number is a number that has more than 2 factors. Prime number, 2 factors. Composite number, more than 2 factors. So 3 or more, right? Prime number, 2 factors. Composite number, 3 or more factors, all right? So for 6, my factors are 1 and 6, because 1 times 6 equals 6. And my factors are also 2 and 3, because 2 times 3 equals 6. So 6 got 4 factors. 6 got 4 factors. 14, and again, you need to know your multiplication facts. If you know your multiplication facts backwards and forwards, like the back of your hand, then this exercise is going to be easy. You want this exercise to be easy. So if you don't currently know your multiplication facts and have them memorized, do yourself a favor. Practice reciting your multiplication facts every single day until you memorize them. All right. Now, 14, we got 1 and 14. And we got 2 and 7. Because 1 times 14 equals 14, and 2 times 7 equals 14. So 14 also has 4 factors. Now, what do I do now? The C stands for common. I'm going to circle all the numbers that are in both lists. Both lists. So I see 1 in this list. I see 1 in that list. And then I see 6 only in that list. So 6 is no good. And what you could do, what you might want to do is cross off the numbers that are not common to make things seem easier. So 6 is in this list and not the other one. So cross him off. 2 is in both lists. 3 is in this list, not the other one. 14 is in this list, not the other one. 7 is in this list, not the other one. So what are my common factors? What are my common factors? Whatever's in both lists is common. Whatever I circled, that's in both lists. 1 is common. 2 is common. Now the G comes in, the greatest. What's the bigger number out of 1 and 2? 2 is. 2 is the bigger number. So 2 is your greatest common factor. 2 is your greatest common factor. All right? 2 is your greatest common factor. Now let's do this last example and then we're going to get out of here. All right? I'm going to let you go get some practice with finding GCFs out of just random pairs of numbers. And we could do 3 numbers, right? If we had 3 numbers, we would just list all the factors of all 3 numbers and do the same process. We would just circle the numbers that are in all 3 lists and then figure out the G, the greatest number out of all of them. So for 12, I got 1 and 12. Then I got 2 and 6. Then I got 3 and 4, right? How many factors is that? 1, 2, 3, 4, 5, 6. 6 factors. That's 6 factors, right? And then for 32, I got 1 and 32. I got 2 and 16. I got 4 and 8. I think that's it. Yeah, because 1 times 32, right? Because 1 in itself is a factor of every number, right? 32, 1 times 32. Now, I know 32 is an even number, so therefore it's got to be divisible by 2. And this is just another math trick that I'm giving you. When your number is an even number, you know that 2 has to be a factor of it. Write that down, right? And then memorize it. If the number is an even number, 2 has to be a factor of it. So if 2 has to be a factor of it, ask yourself 2 times what number would equal 32? Or do the division. You can just write it out on paper. Do the division. Do 32 divided by 2. And then you would have figured out that 16 is the other factor because 2 times 16 equals 32. All right? Now, multiplication facts. I know 4 times 8 is 32. So 4 and 8 are also factors of 32. Now, how do I know I'm done? Well, 5 is not a factor of 32. 6 is not a factor of 32. 7 is not. 8 is, but I already listed 8. Right? And as I keep going higher with my factors, I'm going to reach 16 again and 32 again. So all these are listed. Now, these are all the factors. That's the F part. That's the F part. These are all the factors. Now we go to the common part. What's in both lists? 1 is in both lists. Is 12 in both lists? No. Is 2 in both lists? Yes. Is 6 in both lists? No. Is 3 in both lists? No. Is 4 in both lists? Yes. And then down here, 32 is not in both lists. 16 is not in both lists. 8 is not in both lists. So what am I left with? What's common? 1 and 1. I got 1 and 1. I got 2 and 2. I got 4 and 4. Now we go to the G part. What's the greatest? The 4. 1, 2, and 4 are common. What's the biggest number? 4. So 4 is our solution. That's our GCF. All right. And from that, we can do a lot of things. We can reduce fractions with that, using that information. Like I said, we can use it in algebra later on, factor in expressions. We can do a lot of things. Simplifying expressions, a lot of stuff. Trust me. All right. But make sure you understand what a GCF is, right? Make sure you understand what a GCF is, be able to speak intelligently about what a GCF is. Also be able to figure out what a GCF is when you're given a couple of numbers. When somebody give you 2 numbers, or if somebody give you 3 numbers or 4 numbers, know the process. And look, I wrote all this down, right? But over time, like in real life, I don't write this down. I just know it off the top, right? That's because I have a lot of practice. I've had a lot of practice over the years. In time, once you have a lot of practice under your belt, you're not going to need to write all the factors down because you're just going to know them. And then you're going to just remember patterns and relationships between numbers, right? Just like with video games. You just remember what to do on video games, right? So you don't really got to spend a lot of time like writing down things and all that. You're just going to know because you'll just be familiar. All right. So go get some practice finding GCFs and I'll catch up with you on the next video. Peace.